Did you know that not all stars flare with the same power? Some barely glow, and others can unleash explosions strong enough to sterilize entire solar systems. Today, we're ranking every major type of star, from weakest to strongest, by their average flare strength. Let's begin at the bottom. Brown dwarfs, the failed stars. Too small to ignite hydrogen, too big to be planets. Their flares are weak, a fraction of a small solar flare. Think cosmic static, M-type red dwarfs, quiet ones first. Old, slow, barely flaring. A-type and B-type dwarfs come next. Hot, bright, but surprisingly calm. Their magnetic fields are weak, so they barely flare at all. F-type stars, hotter than the sun but mild. Their flares hover around C to low M class, nothing too dramatic. G-type stars, our sun's class, solid middle ground chaos. C, M, and sometimes giant X-class flares, like the Carrington event. K-type orange dwarfs, the unpredictable ones. Cooler than the sun, but somehow wilder. They can produce super flares hundreds of times stronger than anything our sun typically generates. Now we climb into giants, red giants and orange giants. These flares aren't steady, but when they erupt, they can exceed anything produced during their main sequence lives. Blue giants and blue supergiants. Now the power jumps. These eruptions can dwarf the largest solar flares by millions. The unstable kings, the unstable supergiants, yellow supergiants, including stars like Cassiopeia. Their outbursts can briefly outshine entire galaxies in ultraviolet light. Not the strongest, but incredibly destructive. Now the heavy hitters, Wolf-Rayet stars, nuclear furnaces blasting away their own surfaces. Their eruptions can exceed solar flare energy by a factor of 1 billion. A Wolf-Rayet star within 25 light-years could kill Earth with a single event. But now we leave normal stars behind. White dwarfs, dead but dangerous. In binary systems, they produce nova-like explosive flares that release more energy than the sun produces in tens of thousands of years. Now the collapse gets extreme. Neutron stars, unimaginable density. When their crusts crack, they release the energy of a solar system in a split second. A single flare can equal what our sun emits in 100,000 years. Pulsars on rotating neutron stars. Their beams can slice across space like cosmic lighthouses. Their flares are stronger, sharper, and faster. Sometimes enough to shut down satellites across the galaxy. And then, the absolute peak, magnetars. The universe's most violent objects. When a magnetar's magnetic field snaps, it unleashes a flare so powerful it can deform a neutron star's crust and ionize planets from thousands of light years away. A single magnetar burst equals x1020 solar flares. That's 100 quintillion times more powerful than our sun. Anything within 50 light years could be destroyed. The stars around us are anything but peaceful. And somewhere out there, one of them is flaring right now, and we won't see the light for thousands of years.